Okay, we're going to sketch angles that are either greater than 360 and negative angles, also the ones between 0 and 360. So I'm just going to start off by reminding you of, in general here, put the whole thing in if I can. This would be 0 degrees, starting at the positive x-axis is considered 0 degrees. Right at the top is 90. And then over here is 180. Over here is 270. And then back to the start again is 360. Anyone have an idea of how we draw a negative angle? Negative 30 degrees? 7? Yeah, so starting at 0, down here is negative 90 degrees. So we're just our angle's gonna go this way from x instead of this way. This is negative 180, negative 270, and then this is negative 360. So we would draw, remember that angles are directed arrows. That's one thing that people lost marks for on yesterday's assignment, was not putting an arrow on their theta angle. Okay, forgot to. So all our angles, if it's in standard position, it's a positive angle between 0 and 360. Okay. All right, that's good enough for now. So on to question 1. Sketch each angle theta in standard position. Include the principal angle and alpha in your sketch. Okay? So principal angle is always the positive angle between 0 and 360. Okay? So it's from the positive x-axis to the terminal arm. And that's a lot to write down, so I'll give you some time there. So the principal angle is always positive. It's always between 0 and 360. It's always drawn from the positive x-axis to the terminal arm. Does anyone remember from a week ago what alpha was? Where alpha fits your diagram?
It's like equilibrium.
It's okay. Yeah, it's the angle we try to find using tan to help us find out our principal angle. Okay, if we don't know it, alpha is called the related acute angle. It has a name now instead of just alpha. Related acute angle. And it's always between the x-axis and the terminal arm. And it's not directed, meaning there's no arrow. Can never be negative. Alpha can never be negative. Okay? So alpha is called the related acute angle. It's always between the x-axis and the terminal arm. It's not directed. It can never be negative. You don't put an arrow on it. Okay? Just has a size. And then theta is just whatever angle they give us. Okay, so we're going to start off with the angle 510. So remember, if we're looking here, we're going 0, 90, 180, 270, 360. If I keep going, 90 more than 360 up here is 450. Okay? And 90 more than 450 is 540. So do you guys agree that 510 is going to be in the second quadrant? Okay? Is it going to be closer to the x-axis or the y-axis? How do you know that?
It's 510.
And so there's only 30 degrees more to go to get to 540. Okay? So that means that it's going to be like a 30-degree angle here. So I would take my ruler. And remember, 45 is the halfway. That's how you know whether it's halfway. So we want it closer to the x-axis. Arrow on the end. Okay, so we're drawing all three angles. First, let's draw theta. So theta is 510 degrees, so it's all the way around once it's 360, and then over to the terminal arm is 510. So this is theta. Okay. Alpha doesn't have an arrow, it's just this angle in here. And it's probably easier to find alpha after we find the principal angle. The principal angle is the angle from the positive x-axis to the terminal arm in its direction. And I just call it P dot A dot. Anyone know how I can figure out how big the principal angle is? Yep. Yes. So we're going to take 510, which is all the way around and then over here, and subtract off 360, which takes off this whole loop here, right? So that all I'm left with is this much, which is the principal angle. And what happens if you do 510 take away 360?
150.
So 150 degrees is my principal angle. Okay? So if I know from here to here is 150, what's alpha going to be? 30, and that's because, Jack?
Because 180 minus 150.
Right. From here to here is 180, so 180 minus 150 is 30. Okay? So now you've drawn your diagram, you have theta drawn, you have alpha on, and you have the principal angle on. Okay? So all three angles are shown on your diagram. Okay, 585. So we said that to here was 540, right? We can draw them all on for reference here. So 0, 90, 180, 270, 360, and 90 more is 450, and 90 more is 540, and 90 more is 630. And I want to know where 585 goes. Closer to the x, closer to the y, or in the middle. So 585, we know it's in this quadrant. If I want to know where it is, I'm going to do 585 minus 540, right? And that'll tell me where to draw it in that quadrant. It's 540 is my next closest marker there. And that gives me 45 degrees. Everyone see that? So that means it's right in the middle. So you want to make it look like you're right in the middle. Which means that we already know alpha is 45 degrees. Alpha is always between the x-axis and the terminal arm. And it's not directed, it's just a little angle thing. Okay, so now we want to draw 585. So starting at the positive x-axis, we're going to go around once, and then around again until we hit the terminal arm. That's theta equals 585. And then the principal angle is from the positive x-axis to the terminal arm, and it is directed. And again, we can get it by subtracting 360. $225. So the principal angle is 225 degrees. Remember, the principal angle is always positive, and it's always between 0 and 360. And it's always from the positive x-axis to the terminal arm. Negative 120 degrees. So we know we're drawing a negative angle, so I'm going to start at 0 and then put negative 90 down here. Negative 180 over here. Negative 270 at the top. And negative 360. So remember, it's quadrant 1, 2, 3, and 4. Which quadrant is the angle negative 120 degrees going to be in? 3. Okay. All right. Is it going to be closer to the x-axis or the y-axis? Okay. Good. So then draw it in. Closer to the y-axis. So this time when you're drawing theta, it goes clockwise. So like this, with an arrow, it's directed. That shows it's negative angle. And we know it's negative 120 degrees. My principal angle is the angle from 0, positive angle from 0 around till it hits the terminal arm. Any ideas how to find the principal angle if we're starting with a negative? Add 360. $240. Our principal angle is 240. What about little alpha in here? Alpha is going to be then 240 minus 180. Alpha is always positive. Alpha can't be a negative angle, it's not directed. So 240 minus 180 is 60. So alpha is 60 degrees. 240 minus 180 is 60. Okay, the next angle we're drawing on here is negative 330. All right, I'm going to give you guys just some time to try it. Okay, so what's the general consensus closer to the x? Let's see why we thought that. So our angle was negative 330, so we can see that negative 330 is only 30 degrees from negative 360, so it should be closer to the x-axis. Is everybody good with that? And then to draw it in, it's going clockwise from the positive x to the terminal arm. So that angle is theta equals negative 330 degrees. Okay? And then alpha is 30, because we know the angle in here is 30. That's how we knew how to draw it closer. But that's also going to be the same as the principal angle, which is always drawn from the positive x-axis to the terminal arm and is directed. Okay, so you do need an arrow for the principal angle, which is also 30 degrees. So in this case, alpha and the principal angle, any first quadrant, alpha and the principal angle will be the same anytime your angle's in the first quadrant. Any questions about how to get any of those three angles in there, in that specific question? Basically, they're definitions, and you have to work with them. Really good? Okay, the next one, 1020. Okay. So we're going to start with 0, 90, 180, 270, 360, 450, 540, and 90 is 630, and 90 is 720, and 90 is 810, and 90 is 900, and 90 is 990. Am I going off track here? Or am I good? Hi. Thank you. 184. And then 90 more is 1080. How far do we want to go? 1020. So we've got there. So it's going to be in the third quadrant. And this is to 1080, but we only want to 1020, so is it going to be closer to the x-axis or y-axis? Yeah, because 20 to 80 is 60. Everyone see that? Okay, so it's going to be closer to the y-axis. All right, so I'm going to wait till everyone's got their terminal arm drawn in. It's a positive angle, so all the way around once is 360. That takes care of that, okay? All the way around again is 720, and we're not going all the way to 1080, but we're going towards it. So all the way around until we hit our terminal arm. That is theta equals 1020 degrees.
Do we ever find angles like this in real life?
Yes.
1,020 degree angle?
Yes, like, okay, so the next lesson today is finding the sine, cosine, cosecant, secant, cotangent of angles like that, okay? And then Thursday we're graphing, so we're putting sine and cos only this year in grade 11 onto a xy axis where the x-axis is angles, so it can go on forever in either direction, and the y-axis is the sine or cos value, okay? So yes, there is, it's not just, you know, in an insane, fun spiral drawing class, there is actually math behind it. Everyone always says that this year, like, what? But, and I get it, but it is a building block towards something that you're going to have to know what it means. All right, so you've got theta drawn on, we've still got two other angles to draw in. One of them is alpha, which is always between the x-axis and the terminal arm non-directed. And so 1080 minus 1020 gives me alpha, which is 60 degrees. Remember, alpha is never negative, so even if you calculate with negatives and you get a negative, just make it positive. Okay? Alpha is non-directed. Just make sure that the biggest mistake people make for alpha is they put it, they find an angle between the y-axis and the terminal arm accidentally. Just always make sure it's between the x-axis. And then our principal angle is the angle from here to here with an arrow. And this time, we're going to start with 1020, but we're going to keep subtracting 360 until we get to a number between 0 and 360, right? So the first time we subtract off 360, we're at 660 still. So then we're going to subtract off 360 again. And we're at 300 degrees, which is a positive angle between 0 and 360. It makes sense for it to be 300, being in the fourth quadrant. Our principal angle is 300 degrees. So every time you add or subtract 360, you're getting rid of or adding a loop. Okay? A full loop. One way or the other. All right, any questions about any of those three angles that we put on our chart? Okay. Negative 660. Okay, so it's going to be similar. We're going to start off naming our axis. So 0, negative 90, negative 180, negative 270, negative 360, negative 450, I'm just adding 90, negative 540, negative 630, negative 720. And what is it, negative 660 we're drawing on? So it's going to be in the first quadrant, guys. Closer to the x or the y? The y, because we're at negative 630 here, and we only need to go to negative 660, which is only 30 degrees more. Okay? So it's closer to the y-axis. It's negative, so we go clockwise, so we're going to go, one full loop around backwards is negative 360, and then back to negative 660. So that's theta equals negative 660. So we got to put alpha and the principal angle, which in the first quadrant are going to be the same thing, same number. So to get the principal angle, I start with the angle I'm given, negative 660. If it's negative, I'm going to add 360 and see where I'm at. So negative 660 plus 360 is negative 300, which is still not between 0 and 360. So then we're going to add 360 again. And this time that gives us positive 60. Which is a positive angle between 0 and 360. So our principal angle is 60 degrees, but in the first quadrant, alpha is also 60 degrees. The angle between the terminal arm and the positive x-axis, or the x-axis. Okay. 690. Okay, I'll give you guys a chance to try that. Yeah, so this is positive, so I'd start off with 0, 90, 180, 270, 360, 450, 40, 610, 720. So it's going to be between 610 and 720, closer to 720. So closer to the x-axis. Any questions?
I think closer to the one because it's 630 at the bottom, it's not.
Yeah, it's 630 at the bottom and then 690 right.
Okay,
So there would just be a straight line.
you're right.
One, 610, one should be 630.
Yeah.
Yes, yeah. I didn't think so. So 630 and 720. So 690 is going to be 60 away from 30. Do you agree with that? So it should still be closer to the x-axis. Do you agree? Okay. Okay, so this is 630, we want 690, so that's 60 degrees apart, which means it's just only 90 degrees in that quadrant, so it's closer to the x-axis. And then, so we want to go all the way around once, that gets me to 360, and then all the way to the terminal arm gets me to theta equals 690. And then my principal angle is from the positive x-axis around to the terminal arm. So I'm going to do 690 minus 360. And that gives me 330. My principal angle is 330 degrees, which makes alpha 30 degrees. That's from 330 to 30 is. Thank you.
You're welcome. You good?
Yeah.
Okay.
Yeah, from 330 to 360 is only 30 degrees, so alpha is 30. Any questions for this one? All right, next one. Now you're drawn, the angle's drawn for you, and you have to figure out what angle the red one is, the theta that they drew on. Anyone have any ideas how you would go about doing this type of question? Yep.
Well, since theta's going down, it's negative.
Okay, so the first thing I would ask myself is just what Jack did. Is it going to be a positive or negative angle? And then I kind of would, if I know it's going to be a negative angle, then just at the end I'm going to make it negative. I'm not going to work with negative numbers. I'm just going to know that my answer is going to be negative. Okay? So if I don't include negatives, does everyone agree that this whole angle is 180? And then this much is 44, so theta is going to be negative 180 minus 44. Does that make sense? So the negative's just out front. I'm not using it in my calculation, but I know that in the end I'm getting a negative angle. So then 180 minus 44 is 136 degrees. So theta is negative 136 degrees. So I really like that Jack's method of before you even start, decide whether your answer is going to be positive or negative so that you can always look back and make sure that you did that right. Okay? So same thing here, look at your angle and decide whether it's going to end up being positive or negative. So it's going this way around, so it's going to be positive in the end. Okay? So then I kind of, every time I see a spiral, I count that as a 360. So here's one complete spiral, so that's 360. Everyone good there? So you know it's going to be bigger than 360. And then I know this much here is 180. Do you agree with that? So I can add 180 on first. Or if I want to do it like this, I could do theta horizontally is 360 plus 180 minus 34. Or you can do it in stages. Do the 360 plus 180, get that answer, and then subtract 34, and then get your final answer. Does that make sense? So you go 360, you add 180, but then you have to subtract off the 34.
No.
What do you get? 506. And just check that it's positive so that you don't forget about the positive and negative. That's one of the most common things is you focus on getting the number, but you totally ignore positive or negative. Co-terminal angles are angles that have the same terminal arm. So if we look back at our diagram here, actually this one is a good one. So 690 and 330 are co-terminal. So that's just a definition again. But any angle that has the same terminal arm, they're called co-terminal angles, okay? So 690, you land right in this spot, and same for 330, you land right in that spot. So they're co-terminal. So if we look back at H, or F, sorry, negative 660, and the principal angle, which is 60, are co-terminal. They have the same terminal arm. Here, 1020 and 300 are co-terminal angles. They have the same terminal arm. Okay? So any angles that have the same terminal arm, that's the definition, are called co-terminal angles. Okay? So sketch the angle 848, state one positive and one negative angle that are co-terminal with 848. So I'll give you some time. Starting. So we know it's going to be between 810 and 900, closer to the 810. Everybody good? So closer to the y-axis. So if I'm drawing on theta, it's going to be all the way around once, that's 360, all the way around again, that's 720, and then to 848. So there's theta equals 848 degrees. So if I were to find the principal angle, would the principal angle be co-terminal? principal angle at the same terminal arc? So just finding the principal angle gives me an angle that's coterminal. Okay, so I can do that by doing 848 minus 360 which is 488, still bigger than 360, so subtract 360 again. And that gives you 128 degrees. So that means, therefore, one positive angle coterminal with 848 degrees is 128 degrees. Would this angle, 488, be a positive angle coterminal? Eva's nodding her head. Why, Eva? So yeah, it is, right. So that 488 would be all the way around once and then to here. I put a little arrow there. I don't want to, but it would be all the way around once is 360, and then 128 more gets me to 488. Okay, so 488 would be one loop and then 128 degrees, whereas 848 is two full loops and then 128 degrees. Okay, they all end up in the same place, so that's also coterminal. So if we're looking at coterminal so far, I'll use green for coterminal, that's coterminal, and they're coterminal with that. They're all positive. How would I get a negative angle coterminal? Okay, so if I take my principal angle and I'll use blue here and subtract 360, then I'm going to get that angle, which is also coterminal. Okay, so that's going to be 128 degrees minus 360. Which is negative 232 degrees. So that angle there is negative 232 degrees. So that would mean that one negative angle coterminal with 848 degrees is negative 232 degrees. So the big thing about finding a coterminal angle is either adding 360 or subtracting 360. So if you start, or get your calculator and start at 848, you should be able to keep subtracting 360s and eventually end up at negative 232. Okay, so try it. So let's try 848, subtract 360, I'm at 488. Subtract 360 again, I'm at 128. Subtract 360 again, I'm at negative 232. Okay? So you can always either add 360s or subtract 360s to find coterminal angles. And if you need specifically to get a negative one, you just keep subtracting until you get to a negative. Subtracting 360. Okay? If you're in the negatives and you need a positive, you keep adding 360 until you get a positive one. All right? Okay, so here's our last example. I'll give you time to... It's negative 430. Did you guys get fourth quadrant closer to the y-axis? Yeah? Okay. And it's gonna look like, so all the way around in the negative direction, one loop, and then to here. So that's gonna be theta is negative 430. So we should be able to add, well, if we find the principal angle, that'll be a positive, because it always is, so we usually always find that one for my positive angle. So it's going to be negative 430 plus 360. That's negative 70, still negative, so I have to add another 360. It's going to give me 290. So principal angle is 290, which means that therefore 290 degrees is a positive angle. Co-terminal with negative 430 degrees. So these are co-terminal, but on our way to getting the negative 430, we got a negative 70. Is that also co-terminal? Yes, that would be like going from here to here. That would be negative 70 degrees. Okay, so negative 70 degrees is a negative angle. Co-terminal with negative 430 degrees. Any questions for that one? Okay, I will give you the practice.